Welcome to SolidCAM Professor in a video series to help you get started with iMachining. In this session, we will discuss how to use the iMachining technology wizard. This will include step down, the machining level slider, output cutting data, the dynamic 3D preview window, and effects of turning the wizard off and back on. We will continue to use the same mill and cam part with iMachining operation that we've just used in our previous two videos. The Technology Wizard is an algorithm for producing on-the-fly cutting conditions for the current iMachining operation. In the Technology Wizard branch, we can see the cutting conditions and their selections. There are four sections of the Technology Wizard dialog: Step Down, Machining Level, Output Cutting Data, and the 3D Preview window. The Step Down section consists of Input Options and the Output Grid. The Output Grid has three columns: Number of Steps, Step Down, and ACPs. Rows are created for each step down value that is not the same. The ACP value coincides with the color of the step down row, as shown in the previous video, defining a tool. In this example, the field is painted green, meaning that this is a good situation for stability. The step down by default is set to automatic. Automatic will provide step downs based on the defined tool information and the pocket depth. There are two radio buttons for selecting the way the wizard calculates the depths: automatic and user defined. Because our pocket depth was set to a nominal 30 mm, automatic generated two steps at a 15 mm depth with an ACP value of 2. Let's click Save and Calculate, and then simulate to view the toolpath using these step down values. When the simulation control panel opens, let's use the default HostCAD mode. Let's press play to display the wireframe toolpath on the model. Let's zoom into the pocket to get a closer look at the toolpath. Slow the simulation speed down and then press the play button again. We can see the two step downs are shown. Let's exit the simulation to display the Technology Wizard. Now, let's set the radio button to user defined under step down. A drop-down menu appears and enables us to manually enter a specific number of steps or step-down value. If the drop-down is set to number of steps, the total depth will be divided up by the number of steps. Let's enter 4 steps in the input field text box. Let's calculate and simulate our results. First, click Save and Calculate to calculate the toolpath, and then Simulate to open the simulation control panel. Slow the simulation speed down and then press the play button. We can see the toolpath makes 4 step downs and comes to an end. Let's exit the simulation to once again display the Technology Wizard. Now, let's select Step Down from the drop-down menu. The value in the input field text box will be used for the depth of each step down until the total depth is achieved. Let's enter a 3 mm depth. The results are 10 steps at a 3 mm depth to give us the 30 mm total depth. Let's calculate and simulate our results. Click Save and Calculate to calculate the toolpath, and then Simulate to open the simulation control panel. We'll slow the simulation speed down and then press the play button. We can see the toolpath makes 10 step downs and comes to an end. Let's exit the simulation to once again display the Technology Wizard. Now, when the drop-down is set to step down, it is possible to enter a step down deeper than the cutting length of the tool. Recall the cutting length of our end mill is set to 24 mm. Let's enter a step down of 30 mm, the full pocket depth. Let's look at the results. Click Save and Calculate, and then Simulate to open the simulation control panel. Slow the simulation speed down and press the play button. We can see the toolpath makes only 1 step down and comes to an end. Let's exit the simulation to once again display the Technology Wizard. If we set the drop-down to number of steps, it is not possible for the wizard to generate depths greater than the tool cutting length. Let's try to enter 1 step down. The results are 1 depth at 24 mm and 1 depth at 6 mm. Let's calculate and simulate the toolpath. Click Save and Calculate, and then Simulate to open the simulation control panel. Slow the simulation speed down and press the play button. We can see the two depths are shown that were in the output grid. Let's exit the simulation to once again display the technology wizard. If we want to use number of steps and would like the wizard to calculate one step at 30 millimeters, we will need to edit the tool and change the cutting length equal to or greater than the desired step-down value. Switch to the tool branch and then click Select to display the tool table. Change the cutting length to 30 millimeters. Click Select to accept the changes and exit the tool table. Switch back to the technology wizard. Now the wizard can calculate the full depth. Let's go back to the tool table in the tool branch and return the cutting length to the original 24 millimeters. Then, switch back to the technology wizard branch again. The machining level section consists of a slider that is used to select from calculated sets of cutting conditions. The slider is made of 8 levels. Each level represents more metal removal rate and higher aggressiveness. The output cutting data section consists of 2 different ways to view the final data from the wizard that will be sent to the toolpath. View 1 shows spindle speed, feed rate, step over max, and step over min. View 2 shows cutting speed, chip thickness, cutting angle max, and cutting angle min. The output cutting data should be monitored while using the machining level slider to choose a set of cutting conditions. There are many factors in machining that can make one set of cutting conditions better than another. Some of these factors include fixture stability, cutting tool quality and stability, and/or risks associated with the forces from higher metal removal rates. The milling level slider provides the user with an adjustment for these factors. The 3D preview window provides a 3D representation of the selected cutting conditions. The 3D view shows tool diameter, tool length, tool cutting length, step down, step over, and aggressiveness. The tool is shown in 2 colors, yellow for the cutting length and gray for the remaining length of the tool. If there are multiple step downs, the largest step down from the output grid will be used since it's typically the most aggressive step down and should be monitored. Step over is represented by the red section in front of the tool. As the machining level slider is used to select the desired cutting conditions, the 3D preview window updates. Levels 1 through 5 contain different step over values and the remaining levels have a consistent step over. The aggressiveness is represented by the chips behind the tool. The 3D chips change color, quantity, and size to show that moving up in milling levels produces more, thicker chips with greater heat. Also, the 3D preview window shows how the chips should be evacuating the cutting area under good conditions when actually machining the part. The chips should be coming out the back of the tool. If the chips are sticking to the tool due to heat and are being brought back into the cutting area, then the potential for failure is high. At the top right of the iMachining operation dialog, the wizard on-off button controls if the output cutting data is being written to the toolpath or not. When the wizard is on, the output cutting data is being sent to the locations in the operation dialog to be calculated along with the final toolpath. Spindle speed and feed rate are being sent to the Data tab in the Tool branch, as we can see here. Cutting Angle Max and Cutting Angle Min are being sent to the Technology tab in the Technology branch. The depths are being sent here also. All these fields are locked from being changed and are shown with a lock icon. If we turn the wizard off like so, the lock icons disappear and the fields are open to be edited. Let's switch back to the Technology Wizard branch for a moment. The wizard can still be used, but the output data will not be written to the fields and no changes to the toolpath or G-code will be seen. Let's set the machining level slider to 3 and watch the output data values change accordingly. Then go to the Technology branch and turn the wizard back on. Turning the wizard back on will sync the output values with the operation dialog and put back the lock icons. And this concludes our 3rd session in the SolidCAM Professor video series to help you get started with iMachining, where we went over how to use the iMachining technology wizard. Thanks for watching. Please join us for our next session, where we will go over using iRest and iFinish.